Okay, this is a Winkler that we're working on, and we need to first take this sample that we fixed with the manganese in the alkaline solution, and you can see that it reacted with the oxygen reacted up with all this iodine. So we're gonna basically free up that iodine to get the quantitative amount. So this sulfuric acid will put everything back in solution, and same thing adding under the tip. I mean, there's going to be a little bit of solution there, and that solution has some manganese in it, so we'll mix it, but spill the rest in the sink. You see that cleared up, mostly cleared up that sample from the stuff that was in there. And we need a 50 ml of this. These BOD bottles that we're using are the miniature ones, so we use less reagent, and we can do, for the photosynthesis irradiance, we can do more of the replications. The standard volume here, this 300, but they're just the same. They're just a good bit bigger. So we've got everything scaled to match. And you're going to go up and read from the bottom of the meniscus, 50 mils. And then you go on to the stir bar. And the first step of this is taking this thiosulfate solution and getting it to what's called a pale straw color. And we're using this burette. It's kind of a handy little burette. It automatically fills. So I got it to fill right, and the meniscus is right at the top of the zero. And we use a weaker solution than the standard large scale assay, so we can have the right amount. 1 mil equals 1 milligram per liter oxygen. And we'll turn up the stir. For some reason this is going to take more. Well, that's pretty good. So we're getting close to a pale straw color here. And if you're really good, you can actually just go until it turns clear. But if you want a clear indication, any starch that's in the solution, any iodine that's in the solution, left in the solution, is going to react with starch. And so this should turn it blue. So there's still some of the iodine left, but not much. But when that goes clear, we've got the right amount.
Is there a reason to not add the starch to begin with?
Yeah, you can't really see it because it goes from, if you add the starch to begin with, it goes from dark blue to clear almost instantly, so you don't know that you're close. Whereas you can kind of tell how close you are better with that pale straw color thing. You see it turns a little almost clear, but then it goes back to blue as it reacts a little bit more. So, and I think we're all the way there now. So in this case, we just made it. There was 9.8 milligrams per liter of oxygen in that particular sample.